All right, guys. So welcome back. This is Mr. Moscato with you again. All right. So hopefully you guys went back and read page 156 and 157. All right. And if you haven't, please stop the video, go back, read 156, 157. There's some important concepts there talking about x-intercepts and y-intercepts. All right. You just have to understand, what's going on there. It also talks about the behavior of graphs. All right. What's happening as x values increase. Are the y values getting smaller as x values increase? Are the y values getting bigger? Right. So that determines the behavior of a graph. Right. We've talked about that. Is a graph increasing or is a graph decreasing? Right. If the line's going up from left to right, the graph is increasing, right? The y values are getting bigger. As the x values get bigger, that means that the graph is increasing. If the line is going down, right, from left to right, that means that the graph is decreasing, right? As the x values get bigger, the y values are getting smaller. All right, so that's a decreasing function, right? So it's important that you guys understand those concepts, right? And then the x and the y intercepts. Where does the line, all right, cross the x-axis? Where does the line cross the y-axis? All right. So today what we're going to do is we're going to take a look at graphing a linear equation. All right, using the standard form of the equation and specifically finding the x-intercept and the y-intercept to help us draw our graph. All right, so let me switch over views here. All right, so give me a second. I'll be right back. All right, guys, so here we go. We're at the bottom of page 157. All right, and we're looking at example 4, and it says graph a linear equation. All right, by first finding the x and the y-intercepts, you have the ordered pairs of 2 points through which the graph of the linear equation passes, right? So really, when we're trying to describe a line, all we really need is 2 points. If I can find 1 point, and then I can find another point, all right, then if I draw a line between those two, I can extend the line beyond those 2 points infinitely in any direction, in both directions. All right, and that describes a line. I should be able to figure out all the other points along that line. So really, when you're dealing with a linear equation, right, and you're trying to draw the line, you only need 2 points. Well, the standard form of an equation, remember, is ax plus by, right, equals c. The standard form of an equation helps us to identify the x and the y coordinates very, very easily. Okay, so let's take a look at this example. All right, so graph, right, 2x plus 4y equals 16. Okay, all right, so how do we use the standard form to figure out my x and my y intercepts? All right, so let me draw a quick graph here. All right, that line goes like that. This line goes like this. Okay, here's my y-axis, here's my x-axis. All right, and then we'll figure out some points in a moment. All right, so remember from our conversation in one of the previous videos that the x-intercept, all right, or of a line of a line, right, is where that line crosses the x-axis. The y-intercept of a line is where that graph crosses the y-axis. Okay, when a line crosses the x-axis, that means that y equals 0, right? We talked about that in a video a couple of videos ago, right? When the line crosses the y-axis, the x value has to be 0. Okay, so how do we use the standard form here of this equation to figure out my x and my y intercepts? Well, very easily. If I want to find my y-intercept, right, the first thing that I'm going to do is I'm going to set x to 0. So what happens to this equation when x equals 0, right? So I'm going to put a 0 in for x, so I'm going to say x equals 0, right? So 2 times 0 plus 4 times y equals 16. All right, well, 2 times 0 is going to be 0, right? So that leaves me with 4 times y equals 16. If I divide both sides by 4, y equals 4. So I have the coordinate pair of x equals 0, comma, y equals 4. This is the y-intercept of my graph. All right, so I'm going to go ahead and plot that point. All right, so let me pick a nice color red here. All right, so we're going to say x equals 0, y equals 1, 2, 3, 4. Okay, so this is y equals 4. Okay, and we'll identify that point as 0, comma, 4. Okay, good so far. The next thing that we're going to do is we're going to find the x-intercept. So we're going to take the same equation. All right, we're going to put it over here. Let me just rewrite it here. 2x, right, plus 4y equals 16. Okay, and now I want to find the x-intercept. Where does this line cross the x-axis? Okay, well, when the line crosses the x-axis, the y value has to be 0. So I'm going to find, so the x-intercept over here, right, I'm going to set y equal to 0. Let's do some math, right? So, right, I have 2 times x plus 4 times 0, equals 16. Okay, well, that gives me, right, 2 times x, right? 4 times 0 is just 0, so 2 times x equals 16. What does x equal? I'm going to divide each side by 2, right? X equals 8. So this means that the x-intercept, right? Yeah, I'm sorry, I lost my mind there for a second. All right, the x-intercept of my line, right, is x equals 8, comma, y equals 0. That's the x-intercept. So let's go ahead and plot that point. Okay, so we have a point at 1, 2, 3, 4, 5, 6, 7, 8. Okay, comma, 0. All right, so here we have a point. Right, so this is 8. So this is the point, right, that is described as 8, comma, 0. Okay, now in terms of drawing the line, I'm done. All I need is 2 points, right? All I need to do next, right, is connect those two points. Okay, so let me get a straight edge here, and I'm going to draw a line here. All right. So my line looks like this. Okay, so I can figure out all of my other points along the line, right? Assuming that my graph is correct, I have all of the other points along this line. All right, this is a linear equation. Okay, I find 2 points. I can find the y-intercept. I can find the x-intercept. All right, those are 2 points. I take a straight edge and I connect those 2 points, and that gives me the rest of the line. All right, real straightforward, real simple. Okay, and you know, one of and that's, you know, probably the best use of the standard form of an equation. Okay, of a linear equation. All right, so that's what we have there. All right, I promised you guys in the last video we had this other equation, right, which was what was it? It was 1/3 y equals -1. All right, so if you remember this one from the from page 150, I think it was 154, 155, I think it was 155. Okay, and we decided that this was a linear equation because we could write this as 0 times x plus 1/3 times y equals -1. Okay? So what happens here, right? We have a line in standard form. Okay, let me draw a graph real quick here. Okay, and draw the x-axis this way. Okay, so what happens here? Can I find, do we have an x-intercept, all right, or do we have a y-intercept? So let's take a look at the y-intercept first. Okay, what's the y-intercept? Okay, well, the y-intercept is when x equals 0, what happens, right? So we're going to set x equal to 0, right? So y-intercept, whoops. So the y-intercept, we're going to set x equal to 0. So 0 times 0 plus 1/3 y equals -1. Okay, 0 times 0 is 0. I have 1/3 y equals -1. Okay, so I'm going to multiply, right? I want to get rid of that 1/3. I'm going to multiply that by 3. I'm going to multiply that by 3. So I'm going to get y equals -3. So my y-intercept is at y equals -3. So 1, 2, 3. So we're going to have a point here at -3. Okay, so that's going to be 0, comma, -3. Now, the x-intercept. Is there an x-intercept? Okay, here's where this kind of linear equation is different than all of the others. This linear equation, all right, will not have an x-intercept. Why? Okay, so to find an x-intercept, right, we set y equal to 0. Okay, does this actually give us an equation, right? So I know that I have in standard form 0 times x, all right, plus 1/3 times y. Now, if I'm setting y equal to 0, all right, I'm going to go ahead and do that. I'm going to get that to equal -1. All right, well, 0 times x, right, is 0, right? 1/3 times 0 is 0. Okay, does 0 plus 0 equal -1? No, it does not, right? So 0 does not equal -1. So that means that this equation does not have an x-intercept. No x-intercept. Okay, with me so far? Okay, so what do? Let's just pick another value for x, any value for x, all right, and see what happens to our graph. So let's say, all right, so we're just going to pick another value, for x, okay? Let's say that x equals 5, okay? So what happens when x equals 5? Well, I have 0 times 5 plus 1/3 y equals, right, -1. Well, 0 times 5 is still 0, and 1/3 y, right, equals -1, which means that y, right, equals the same thing as it did up here. Okay, y is going to equal -3. So I have a point, right, of x equals 5, comma, y equals -3, right? Okay, so let's go ahead and plot that point, right? So here we have x equal to 1, 2, 3, 4, 5. And so at 5, -3, right, we're going to have a point here, right? So 5, right, -3. Okay, so what happens here, right? So what's happening is that for every value of x that we come up with, y is always going to be equal to -3. So if we connect these dots, okay, so let me get my straight edge here and draw the graph of this line, what are we going to get? We're going to get something like that. Okay, so this line is a completely horizontal line. It's going to be parallel to the x-axis, right? So it's not going to intercept the x-axis ever, all right? But it is still a linear function. It's still a linear equation, all right, because we can draw a straight line, all right, moving from left to right. Okay, so hopefully that answers your questions about that one goofy example that we had in the last video. All right, and that's how to draw linear equations. All right, so stay tuned for the next video. All right, we'll keep talking about linear equations and trying to figure out all the fun stuff that we can do with them. All right, so this is Mr. Moscato. We'll see you in the next video.